So in problem 52 here, what we have is some hydrochloric acid, okay, which is in this beaker right here, okay, being poured into a beaker that has barium hydroxide. Okay, so that would be this beaker right here. And so what we have is a reaction that's going to take place between the hydrogen ions here and the hydroxide ions there. So our net ionic equation for this particular reaction is still the hydrogen ions reacting with the hydroxide ions to form water. Okay? And what this particular question is asking is, what is the concentration of the hydrogen or hydroxide ions that are left in the solution? So this, again, is really just a limiting and excess reactant problem. So what you need to do is we need to find out how many moles of hydrogen we're starting with and how many moles of hydroxide we're starting with. Okay, and that information is going to come from our given information that we have with the two solutions. Okay, so that's how we're going to find that information. So the first thing to do is to find out what would be the concentration of the hydroxide ions that you have. Find the moles of the hydroxide, of the hydrogen ions. Okay, so that's what we're going to do. We're going to find moles of H plus ions. So you have a 0.250 mole of HCl solution per liter, okay, times a 0.075 liters of that solution. So that's going to give me 0.01875 moles of HCl. And since HCl is a 1-to-1 mole ratio, that means that you have 0.01875 moles of H plus. Then, we're going to do the same thing for the hydroxide solution. So I have 0.0550 moles of barium hydroxide per liter times 0.255 liters. Okay, then that's going to give me 0.0124 moles of BaOH2. Okay, now, one of your issues, though, is the hydroxide ion concentration is a 1-to-2 mole ratio. So my moles of hydroxide are going to be 0.0124 moles times 2. Because for every one of these barium hydroxides, I'm going to get 2 hydroxides out of it. So that means that I have 0.0247 moles of hydroxide ions. So if I go back up to my mice chart, I have 0.0247 moles of those. Okay? And then we have no water to start with. So now this is nice because this is a 1-to-1 mole ratio. So I can easily determine that the limiting reactant is going to be the hydrogen ions, okay, because it's less. So I'm going to subtract 0.01875 moles of that, subtract 0.01875 moles of that. This goes to 0, and this goes to 0.00605. Okay, so to answer the initial question, what is left over in the solution? The hydroxide is left over in the solution. Now, the next question says, what is the concentration of the hydroxide ions in the solution? Well, we have this many moles, okay? So I'm going to go down a little bit. So I have 0.00605 moles of hydroxide ions left. Okay? And to get the molarity, I need to divide that by the volume. But one of the things that you have to remember is for our volume, we had 75 milliliters and 225 milliliters. So right in here right now is a total of 300 milliliters. So my volume is 300 milliliters, which is 0.3 liters. So I have to divide the moles by 0.3, and that should give me a molarity of 0.02, and then depending on how far out you take it, 0.2 molar hydroxide ions. Okay, and that's all that this problem asked for.